Hey, psst, psst. What if was a programming language? That's it. That's the entire video. Make sure to dislike and So how would one make a programming language where the only character allowed is E? Hypothetically, of course. Not like I'd actually waste my time making such a useless language that only uses a few arbitrary characters. Well, I would think there are two major aspects to it. There's the technical side. How does one make a programming language in the first place? And then there's the syntax and design side. Basically, how the fuck does one write these commands out with just this limited character set, and how on earth would that be in any way legible? As far as the syntax goes, for starts I made a bunch of caveats to the E rule. Spaces are allowed to break up symbols, small e's will be allowed, and a capital A will be used as a terminator. Other characters are also allowed when inputting strings. The small e will generally denote the user-defined symbols like variables, and a large E will represent predefined commands, with the exception that numbers will be written as binary, with a big E equaling 1 and a small e being 0. But how are programming languages made? Yeah, I've never done this before, but I can tell you that the basic idea is to make a system that takes a text file with the source code as input, and then outputs machine code as a list of commands. One way is to write a compiler, which is a program that converts the source into machine code once, outputting a standalone executable that can then be distributed to users. The other main method is to make an interpreter, which is a program that reads the source file and directly translates it into commands, executing them in real time. So to answer the question, how to make a programming language, I ask, what is a programming language? Essentially, these compilers or interpreters are the only real parts of programming languages. Interpreters are usually less efficient, so that's what I did. You see, they're easier to make because I can write the interpreter program in another language that already has a good compiler, and then define all of my commands as functions in this other language. Then have that compiler figure out what each of those would be in machine code for me ahead of time. In the real time, the interpreter just has to choose which one of those commands to use, and with what numbers based on the source code. I wrote our interpreter in C because it's the best programming language, and fuck you, let's get into it. Because I have to reuse the same few characters for everything, I had to give this language a very rigid grammar, where the character's position helps determine its meaning. The basic structure is this. You have a command, then you have parameters 1 to n, then you have an A. The command section is written with a row of e's. The tally of the e's is then used as an index in an array of function pointers to each base command. Each function then figures out what to do with the rest of the line of code itself. For example, declaring a variable is command 1. It takes the name of the variable as a row of small e's as its first parameter, then takes a number in E binary as the allocation size in bytes. So declaring a 4-byte integer would look like this. We're only one command in, and the limits of this character set and of my lack of talent are already being felt. There's no real reason why allocate is just 1 E, or why any other command is any other number of E's. It's just the order I made them in. Even I have trouble remembering what command is what. Also, all variable names are just different lengths of E. So goodbye naming conventions. The big A at the end also doesn't do anything yet. Turns out that when you have such a rigid structure, you don't really need terminators. Since every command knows exactly what parameters to expect, it can just ignore the rest of the line and skim through to the next command. I mentioned variables, so let's get into that. And holy crap, are these inefficient. If I want to identify them, then I need to store their names somewhere. And then you still have to allocate and store the actual data itself. Because it's dynamic memory allocation, you need a pointer to that data. In my case, I made a wrapper struct that contains a name as an integer that represents the number of e's, and a pointer to the actual location. And then to keep track of all the variables, I had to link them all in a list, which means another pointer in the variable structure to the next variable. All this means even if a programmer declares a variable for 4 bytes, it's actually taken 16 bytes. And since it's in a linked list, the only way to find a variable from reference is to do a linear search for all the variables. All this is an example of how little control the programmer has over the actual memory usage and the processing overhead in E. I have no idea if this is actually the case with all programming languages or if I'm just doing it wrong. In a similar fashion to the allocate command, I also made commands to assign a value to variables, alter their values, and a command to print either a value or a string to the screen. Not that because of the rigid grammar, you can't do more than one of those things in one line. In C, we could write something like int a equals b plus c, but in our language we would have to write it like this. Everything just takes more lines, and it's much less flexible. One reason is just because I'm not very good at programming, and I have no idea where to even start on making a free-form language where you can have commands inside of commands, like int a equals b plus c, which is actually a declaration command plus an initialization command that contains an addition command inside of it. But even if I did know how to do that, it would be hard to parse it within the E rule. Is this next E a number, or is it the beginning of the subcommand? But enough doom, gloom, and bad language design. At this point, we could at least create multiple variables, set their values, and perform basic math and output to the screen. Then all we needed is a command to get user input, and we'd be able to do something. I wanted to make the base keyboard input command for our language a get key state type thing, where you say the key you're checking for returns a true or false of whether it's been pressed or not, rather than what you usually start with in most languages, which would be pausing the whole program until there is some input in the console window, then reading that input data. I'd rather be able to ask if a specific button's been pressed than ask what's been pressed. And even if for some reason you do need to get a whole line of text and have the program wait for that to happen, then all you need is a command to get each key state and looping to make that for yourself. Oh yeah, I had no idea how looping was going to work yet. I didn't actually think I'd get this far, but it seemed strange to stop there, so I made a loop system before doing the input. Now, the simplest kind of a loop is a while loop, which is just an if statement, but whether it repeats as long as the condition is true. Yeah, I still hadn't done if statements. Well, ifs are simple enough. Find a way of defining a section of code and attach it to a boolean, and have it only run if the boolean is true. Which means before doing ifs, I had to make a system for doing boolean operators for the conditions. You know how I said I can't do more than one thing in one line of code? Yeah, Boolean operators pretty much require it. Most logical operators are comparators. But if I try to write A is smaller than B, then the interpreter will think, okay, A, and then some other stuff I don't understand. It won't know that the result of A is smaller than B is meant to be one parameter in of itself. So I just added the basic logical operators to possible operators for the alter command, which I suppose I should mention that the alter command, the way it works is it takes a variable you want to alter as its first parameter, and then a row of big E's that maps to a function array of operands, the same way as the commands do, and then there is a final parameter that is the value by which to alter the given variable. The operand function returns the altered value, and then the alter function sets the variable's value to that. What this means is the logical operators are kind of weird, because it could take an integer variable and compare it to another integer, and then override the integer variable with a boolean result of that. In order to get the result of A is equal to B, you first have to make another variable to store the result and set that to the value of A, and then alter that by is equal to B. Now we could retrace our sets to my transients and create the if system. You can't actually write the logical operators inside of the condition directly. You have to calculate and store the result of whatever operation inside of a variable ahead of time. If that condition is true, then you just continue reading to the next lines, like the if wasn't there. But the interesting thing about if is that the challenging part is what happens when false. Then you have to make a skip to the end if, which you have to find some way of denoting and identifying. But if you want to have nested ifs, then you need to make sure it pairs if it's correct end if. Shockingly, once I got past the inevitable typo level errors, the if command worked perfectly. Although it feels stupid that it takes 3 ifs and a for loop just to implement one if and e. Then we could do looping, because it's just an if but where it repeats, right? It actually turned out that the part of my while function that reuses the logic from if is actually quite a small part of the whole. What I found was that the post-tested loop, where you check the condition after each slap, would be easier to implement and more efficient. An if only goes the one way, where if the condition is false, the end of the statement is skipped to. But for a pre-tested loop, you first need to do that, but if the condition is true, then it continues processing until the end loop is encountered, where you have to do the reverse of what if does and find the beginning of the loop and jump there. Only so if the condition is then found to be false, it has to jump all the way back down again. And that's expensive. All I said, I've made myself make it pre-tested anyways, because it's just more intuitive for users. One of the things I did to help handle all this is I made loop objects, and I keep track of the conditions and the loop start position in the file. So that way the loop ends can just test the condition directly, easily setting the file reader back to the start. Oh wait, I didn't mention that, did I? Yeah, I've just been streaming the source text directly into my program this whole time, which isn't nearly as smart as using the word streaming makes me sound. And then I linked these loops objects in a stack to handle nesting. Basically these loops are do whiles pretending to be whiles. Finally I fucking added the get key state command. But that was the last command I did for this terrible language. The E limitation and the way I decided to denote commands meant that writing the input command takes 7 E's, which is hard to tell apart from 6 E's, but it's too late to change the syntax structure now. Every project you see has a life cycle. And at some point, if you keep trying to build upon what you have, you're playing a losing game. And look, if I have to type another fucking E in my life, if I were to start again, I would take a much more object-oriented approach. It's honestly kind of embarrassing how noobish my implementation of this is. But now we can get some user input. It takes a key code which can be formatted as a single character for letters and numbers, or as a key code directly. It then takes a variable to store the result in. Here we have a program that loops until the A key is pressed. Added error handling and general safety checking, which, I just kind of put off till now. So that way when you inevitably write your code wrong because you're not as smart as me, the interpreter will tell you why you're stupid. Now I can test my language's usability by putting it through the most horrific, toughest test I can possibly imagine. Teaching it to a child.
No, sir. No. I'll put my own names in. Thank you very much. Okay, so this is the way that... So this is dramatic. This is, shut up. This is look at the screen. This is an interpreted language. What that means is that you write the code in this e.txt file, and then once you save that, you double click on the e.exe. So the way this language works...
What happens if I just press E?
It'll do error. It's a very specific way you do it.
E.
No, stop it. Well, first off, there's 3 characters you're allowed to use for the most part. Technically 4. There's a capital E, a small e, and then at the end of a sentence, just like you put a semicolon in C, you put an A, like the meme.
E-A.
Yeah, it's in the E.
How do you write text?
Okay, so the way this language works is you start every sentence by writing a bunch of big E's, and the number of the big E's corresponds to the number to which command it is. So command number 1 is 1 E, command number 2 is 2 E's.
What does that have to do with command number 1?
So command number 1 is to make a variable.
Variable. Command number 2 is
to assign a value to a variable.
3?
3 is to then change that value somehow.
What is the one for text?
I'm trying to remember. Yeah, because I made that one the 4th. So printing is to do 4 E's.
4 E's, then
a space.
Then a space.
And then the way you do it is you have to format it, just like how in C you have like the percentage D or percentage S. We have to tell it. There's only 2 formats, so it's simple. Just like how you do a certain number of E's to map to command 1, command 2, you have format 1, format 2, which are those E, which are also done with big E's. So since if you want to, what do you want to print?
I want to print text.
That would be format 2. So you do 2 big E's. Two big E's. Yeah. And then space, and then you just type what you want to print. Now, normally you put a big A at the end, but when you're printing text, you don't.
What happens if I do spaces between it? Like if I spell like Rick Roll and spell it where like between the words Rick and Roll,
so
there's a
space. Print, it goes up until until you press enter, till the new line character, and it prints the new line character as well.
Oh, so I can do it with. So it won't.
So you can print a whole line at once. What's difficult is you can't print any less than a whole line. So that's one of the reasons it's pretty useless for actually making new things, because you can't like print half of a line.
Sub to YTP
walrus.
koala.
No, to walrus. Sub to. We're gonna say sub to.
Oh,
this is censorship in action, people. Okay, and then you have to press enter to have it know that that's the end of what you're trying to print. Now, do you want to do anything after that, or do you want to just do this and see what happens?
I want to just do this.
Okay, so you have to save it. So you do Control S. You can't do anything. Oh, you can type. Oh my gosh, I did not know that. I think you just invented programming.
I want to make a text adventure with E because it's so simple. I love it.
Okay, well we need to get into some of the other commands though. So a variable is a place to put a number.
Place to put a number.
Yeah.
How's that for? Listen, you could easily just get You can easily just get your numbers and put them in a box and sort them out.
Yes, that's what a variable is. A variable is a box. A variable is the box you put numbers in. And the important point is that the variable allows you to put a name on it, where then instead of having to know the number, you can just write the name. So, tell me what kind of program you want to make, and then we'll try to figure out how to make it.
Have it where if I press a button, it brings up another piece of text that wasn't previously on there.
So if you press any button or a specific button?
Specific button.
Okay. So if you press a button, it does another message?
Yeah.
Okay, so
I can make a text adventure.
Is it, I don't have scanf like you do in C where it waits. I have it where it just tells if a specific button's been pressed, but it doesn't wait for it to be pressed. So what we need to do is we need to make our own program that makes it wait for us. Now there's one more thing we need to do. So what are we trying to do here? Can you explain what's happening?
I don't know, if you press a key, it loops, I guess.
No, it loops until you press the key, until you press A.
What happens if I press A? Can I have a word can do text?
So what we're going to do is we're going to write the text beneath this part. And then once you press A, then it'll stop looking for A and then go down to the next part where then it prints text. So there's one problem with this. Let's look at this. So this thing, what's going to happen, I want you to go through this thing, what's happening. So it makes the variable E. And then assigns the number 3 to E. And then this thing's going to check if it's a 0.
Okay, let's try it and see if it works.
Okay.
Let's see if it
works, man. I'm
going
to tell you it's not going to work.
How? Wait, did you actually
wait,
write
this is an error. Let's read it.
Space is required.
Space is required after variable reference. Okay, so I know where the problem is. What? So why is that not working? Why is it saying there's still unclosed loops? The loop has been closed. I never thought I'd be this confused by my own error messages.
Well, that was a waste of time.